NOAA's Climate Prediction Center just made a genuinely significant change to its own El Niño forecast, and the number behind it is worth sitting with for a moment. Back in June, forecasters put the odds of this event reaching very strong, or super, El Niño status at 63%, a figure that itself had already marked a meaningful jump in confidence from where the outlook stood just a month or two earlier. In the agency's most recent monthly diagnostic discussion, that probability jumped to 81% for the October through December window, a substantial upgrade in confidence within the span of about a month. At the same time, independent monitoring out of Australia's Bureau of Meteorology confirmed the weekly Niño 3.4 index, the primary benchmark scientists use to track this exact phenomenon, hit 1.94 degrees Celsius above normal for the week ending. July 26th, after peaking even higher at 2.1 degrees just 2 weeks earlier, readings that already sit within super El Niño territory on a weekly basis, well before the event has even reached its expected seasonal peak. This is the story of exactly what changed in this forecast, why forecasters are now this confident this event will rank among the strongest ever recorded, and what that upgraded confidence actually means heading into the back half of this year. No exaggeration, just what NOAA's Climate Prediction Center, the Bureau of Meteorology, and the researchers actually tracking this data are reporting. Drop a comment and tell me if you have noticed unusual weather where you live this year that you now suspect might be tied to this event, because forecasters say its influence is only going to grow stronger from here as the year moves toward its expected peak. I read every one of these. If you want grounded science coverage instead of recycled panic, subscribe. It is free, and a like helps this reach people before this pattern's biggest effects actually arrive. Let us go for 5,000 likes on this one. Now let us get into it. To understand why this upgrade matters, you first need to understand how scientists actually measure an event like this one. The Niño 3.4 index tracks sea surface anomalies across a specific stretch of the central and eastern tropical Pacific Ocean, comparing current readings against a multi-decade historical average for that same patch of ocean. A single week's reading can bounce around noticeably, which is exactly why forecasters wait for a sustained 3-month average rather than any single week's number before formally classifying an event's strength. That distinction is precisely why the two figures in this story, a peak weekly reading of 2.1 degrees in mid-July and the Climate Prediction Center's own seasonal probability estimate, are both meaningful without being the exact same measurement. The weekly number shows how hot the ocean is running right now. The seasonal probability reflects how confident forecasters are that this heat will hold up as a sustained 3-month average once the event reaches its expected peak later this year. Scientists also track a broader set of atmospheric signals alongside ocean alone, since El Niño is not simply a patch of warm water, but a coupled ocean atmosphere phenomenon, meaning the wind patterns, cloud cover, and pressure differences across the tropical Pacific all need to shift in tandem with the warming water for forecasters to treat an event as genuinely locked in rather than a temporary ocean temperature spike that could fade without ever fully coupling to the atmosphere above it. The trajectory behind this upgrade has been genuinely consistent all summer. The observed sea surface temperature anomaly averaged just under 1 degree Celsius across April through June, climbed to 1.55 degrees for June alone, and then jumped further to that 2.1 degree weekly reading centered on July 15th. The Bureau of Meteorology's own independent tracking confirmed the index warmed by roughly half a degree over just the 2 weeks leading into July 26th, alongside atmospheric signals moving in, lockstep with that ocean warming weakened or reversed trade winds across the western tropical Pacific, suppressed cloudiness over the maritime continent, and a southern oscillation index sitting at a strongly negative reading of -28. Every one of those signals independently confirms the same underlying pattern rather than relying on ocean temperature alone, which is part of why the Climate Prediction Center's own diagnostic discussion expressed very high confidence that this event will continue strengthening through the remainder of the year, with a 97% chance of persisting all the way through early 2027. That level of agreement across so many independent measurements, ocean heat, wind direction, cloud patterns, and atmospheric pressure, is exactly what separates a forecast agency's high confidence statement from a more single metric projection, since any one of those signals could theoretically produce a misleading reading on its own. But having all of them move together, this consistently leaves considerably less room for an alternative explanation. Here's where this story takes a turn that adds a genuinely new layer of complexity to an already historic event, one that extends the story well beyond a single ocean temperature reading and into the realm of how multiple, large-scale climate patterns can interact with each other during the same stretch of months. The Bureau of Meteorology's most recent analysis notes that this El Niño's underlying strength, combined with its typical El life cycle, suggests it may persist into autumn of 2027, a notably longer duration than a typical event, which usually fades by the following spring. At the same time, forecasters have flagged a separate ocean pattern, the Indian Ocean Dipole, crossing into positive territory for the first time this year, with its own index reaching 0.44 degrees as of late July, right at the threshold, researchers, to define an emerging event. A positive Indian Ocean dipole occurring alongside a strong El Niño has historically tended to reinforce eye of the same regional weather extremes rather than offsetting them, meaning forecasters are now watching two major ocean patterns developing in tandem rather than a single isolated event. Researchers monitoring the Indian Ocean dipole have noted that models currently suggest a positive event developing through the southern hemisphere winter and persisting into spring, though meaningful uncertainty remains around exactly how strong that secondary pattern will ultimately become and how much it will amplify, rather than simply run parallel to the effects already expected from the strengthening El Niño itself, a combination some climate researchers have started referring to informally as a genuine double climate driver, rather than treating each pattern as an isolated story worth tracking on its own. It is worth being precise about what this upgraded confidence does and does not guarantee, because even an 81% probability leaves meaningful room for a different outcome. The Climate Prediction Center's own strength outlook explicitly notes that a merely strong, rather than very strong, peak remains a real possibility. An independent analysis has pointed out that continued westerly wind bursts across the Pacific, while part of what builds a warm pool in the first place, can also enhance evaporative cooling if they persist too long, potentially trimming the event's eventual peak intensity before it fully arrives. Even the strongest El Niño events on record have never produced identical impacts in every region every time, and NOAA's own forecasters are careful to frame intensity as something that shifts the odds of certain outcomes rather than scripting them with certainty, since a stronger event simply tilts the probability further toward its typical regional effects without guaranteeing any single location experiences them in exactly the way historical averages might suggest. A historic Super El Niño remains the single most likely outcome according to every major forecasting center currently tracking this event, but it is not yet a locked, guaranteed certainty, and the same westerly wind bursts capable of trimming the eventual peak could, in theory, still emerge again before the event reaches its expected high point later this year. There is a useful historical comparison that helps explain why forecasters are treating this upgrade with such seriousness. Super El Niño events, defined by sustained readings of 2 full degrees Celsius, or more above average, have occurred only 5 times since detailed. Record-keeping began in 1950, in 1972 to 1973, 1982 to 1983, 1991 to 1992, 1997 to 1998, and most recently 2015 to 2016, meaning the version of this event now considered most likely by CPC's own probability estimate would place this year in genuinely rare historical company, occurring roughly once every decade on average across more than 70 years of records. Each of those 5 prior events left a distinct mark on global weather during its peak months. From widespread flooding across parts of South Hawaii, forecasters describe the current trajectory as genuinely exceptional rather than simply another routine seasonal update. So what does all of this actually mean if you're trying to understand how this affects the rest of the year? The practical lesson is that this upgraded forecast is not simply a technical revision buried in an agency's report. It reflects growing scientific confidence that the second half of 2026 and the winter that follows will be shaped by one of the more powerful versions of this event in the modern record, with effects reaching into rainfall patterns, temperature outlooks, and hurricane activity across multiple continents simultaneously. That growing confidence is worth factoring into any longer-range planning tied to seasonal weather, whether that means paying closer attention to winter precipitation outlooks in regions historically sensitive to El Niño, or simply understanding that unusual weather patterns already showing up this year are more likely, statistically speaking, to intensify further rather than ease as the year progresses. Given that the Climate Prediction Center's next official diagnostic discussion is scheduled for August 13th, this is very much a forecast still being actively refined, rather than a final word on how strong this event will ultimately become. The honest, grounded summary is this. NOAA's Climate Prediction Center raised its own probability of this El Niño reaching very strong intensity from 63% to 81% within the span of about a month, while independent weekly monitoring confirmed sea surface temperatures in the benchmark Niño 3.4 region have already touched readings as high as 2.1 degrees Celsius above average, squarely within Super El Niño territory before the event has even reached its expected peak. Forecasters now place 97% confidence on this event, persisting through early 2027, with Australian monitoring suggesting it could linger even longer into autumn 2027. A separate positive Indian Ocean dipole developing alongside it adds another layer of complexity to an already historically significant event. None of that makes the outcome certain, since even NOAA's own upgraded 81% estimate leaves real room for a merely strong rather than super peak. And every agency tracking this event has been careful to frame that upgraded confidence as a shift in probability rather than a locked, guaranteed forecast. We are going to keep tracking this exact event the way we tracked it today, straight from NOAA's Climate Prediction Center and the Bureau of Meteorology, not recycled headlines. Subscribe so you do not miss the next official update on August 13th, because based on this summer's trajectory so far, that update is very likely to keep pushing the story further rather than walking it back. And leave that comment below. Tell me what kind of weather shift you're personally watching for most closely as this event continues strengthening, because that is exactly the question. Meteorologists around the world are asking right now too, and cover a genuinely wide stretch of the planet. 5,000 likes on this one. Let us go. See you in the next one.